All right, so to begin, let's find what is the present value of the marginal net benefit for period 2. Suppose the discount rate is 7.25%, so that will give us an R of 0.0725. Okay, so to do present value, right, then we'll take the marginal net benefit in period 2 and then divide it by the discount factor. Okay, R equals 0.0725, years equals 10. Okay, and so simply put it, so we can set it up like so. Simplify the bottom, right? The bottom, so the denominator now becomes 2.0136. That is 1.0725 raised to the 10th power. Okay, so you can see that. Take a second to take a look at that there. Now to make the math a little bit simpler, right? Let's approximate it. Let's round up. All right, let's take 2.0136 and round up to 2. All right. Okay, so marginal net benefit 2, and so we simply write the equation that we had on top, and then we divide. Now, so this then is our new equation. Then this is the present value of the marginal net benefit in period 2. Right? Okay. Now, for a couple of things to observe here. First of all, is the intercept. The intercept had gone down. It got half actually. But it went from 100 to 50. And then secondly, the slope also became less steep. So what we have is a graph that looks like this. Okay. So now let's switch over to paper and let's talk about how we can solve for this. Okay, so before looking at the graph, right, the marginal net benefit was this, but this is unrealistic because we need to discount it, and so now our solution is here. Okay, so graphically we can see that the solution is 150 and 100. That means Q1 equals 150, okay, and Q2 equals 100. Okay, this is graphically. Let's see if we can solve this mathematically. Let's see if we can get the same solution without having the graph. Okay, because a lot of times you're not going to have a nice graph like as easily as this, right? Okay, so here we go. Marginal net benefit 1 equals present value. So that means 100 minus 0.5 Q1 equals 50 minus 0.25 Q2. Okay. Now, you can simplify this a little bit. Right? Minus 50 on both sides. So you get 50 minus 0.5 Q1 equals negative 0.25 Q2. But then you're stuck here. On why? Because if you remember back in algebra, that if you have two unknowns, you have two variables, different variables, then you need two equations. Okay, you only have one equation here. There is no solution. Right? You can give this to an algebra student and they'll never be able to solve it because there's no solution here. So we need to stop and then look for more information. Okay. Now, what other piece of information do we have regarding Q1 and Q2 that we know of? Well, we know that the constraint is binding. Okay, what do I mean by that? The total reserve is 250 tons. Okay, now remember, if the maximum amount that each period wants is 200, so together that's 400. What that means is as long as the total reserve is above 400, then the optimal is trivial. The optimal would just be 200 and 200. However, if the total reserve is below 400, then we need to allocate. Then the both period is not going to get the 200 that they want. Okay, so we know that whatever Q1 and Q2 is, again, we don't know what that is yet. What we do is here, but let's pretend that we don't know. We know that at least they will consume all of it. They will consume all 250 tons. So we'll get that. That's our second equation that we need. All right. So now I'm going to apply the substitution method. Okay, so you can solve this however you want. I'm going to use the substitution method, which is first, let's isolate one of the variables. Okay, Q1 equals 250 minus Q2. Substitute that in, and I'll get this. Now I have one equation and one unknown. I know there's a solution there. Okay, now let's keep going. and done solving, just put a star next to it, and we get, so divide 0.75 on both sides, and then we get 100, which is exactly what we expect, right? And the Q2 is 100, then Q1, okay, must be, and then we can solve for Q1 here. Take 250 minus the 100, we get 150. All right, so we solved it mathematically. Right, that is the optimal allocation, and this will maximize the total social welfare, right, for both periods combined. Okay, now that we have the solution, let's talk about what the areas represent. A represents the total net benefit received in period 1. Okay, so to read this, you just go up to 150, and then you look everything below the curve, up to 150. So the total area here, right, that is the total net benefit received for period 1. B then, right, starting from the right, go to the left, go up to 100, and that is the total, that's the present value of the total net benefit received in period 2. Okay. And what does the $25 mean? The $25 is the marginal net benefit in period 1 and the present value of the marginal net benefit in period 2. Okay. Now I'll just say this is a common mistake. $25 is not the price. This is not supply and demand. This is simply a marginal net benefit. So don't make that mistake. Okay. All right. Now that we have this, now that we know what the optimal is, so the optimal allocation is 150 and 100. Okay. Now we can then let's think about the condition where both periods are not considered. Meaning the current period is not being considerate of the second period, and they ended up using 200 tons. Let's see what happens. Let's see what happens then.